warm welcome to All India Sri Shivaji Memorial Society's Institute of Information Technology, Pune, Maharashtra. I, Mrs. Kulkarni Sheetal V. from Department of Instrumentation Engineering, AISSMS Institute of Information Technology, Pune, Maharashtra. In this video, I am going to discuss Atomic Absorption Spectrophotometer. Contents are Introduction, Principle, Instrumentation, Advantages, Disadvantages and Applications. Atomic absorption spectroscopy is an analytical technique based on the absorption of radiant energy by atoms. Need of AAS. Transition metals require high energy for their excitation, which is not provided by the flame temperature. So, a specific lamp of element to be determined is needed to provide a light of particular wavelength to cause of excitation of transition metallic elements. It is a quantitative type of method. AAS is used for the metal analysis and few non-metal analysis. Principle of AAS is when a beam of light is made to pass through a flame, a portion of light will be absorbed by dispersed atoms in the same manner that a beam of light passing through a solution will be absorbed by the dispersed molecules of a solute. Beer-Lambert's law can be applied to find concentrations using a calibration graph prepared from standards. Absorbance is directly proportional to path, length and concentration. Instrumentation of atomic absorption spectrophotometer. Now we will see first what are the different components. Hollow cathode lamp to emit the radiation. Chopper, it is interposed to break the steady light coming from the lamp into pulsating light, which is used to measure the intensity of light absorbed by elements without interference by radiation from the flame itself. Sample is in a liquid form where the unknown metals are get to be identified. Nebulizer is a component to convert a sample into small droplets or in an aerosol form. Premix type of burner, which is used for the generation of flame with the combination of air oxidant, fuel and sample aerosol. Flame monochromator are used to disperse the radiation according to the wavelength. Detector, the role of detector is to convert the light signal into an electrical signal. Display system for the final output display. First component is the hollow cathode lamp. This is the construction of hollow cathode lamp and it is the actual picture of hollow cathode lamp. When a current flows between the anode and cathode in this lamp, metal atoms are sputtered from the cathode cup and collisions occur with the filler gas. A number of metal atoms become excited and give off their characteristic radiation. In hollow cathode lamp, neon or argon available at a pressure of 1 to 5 torr. The cathode is constructed of the metal whose spectrum is designed or served to support a layer of that metal. Premix type of burner. The fuel and support gases are mixed in a chamber before they enter the burner head where they combust. The sample solution is again aspirated through a capillary by the Venturi effect using the support gas for the aspiration. Large droplets of the sample condense and drain out of the chamber. The remaining fine droplets mix with the gases and enter the flame. As much as 90% of the droplets condense out, leaving only 10% to enter the flame. The 90% of the sample that does not reach to the flame will travel back through the mixing chamber and out as waste drain. Nebulizer is a component which will convert a sample into small droplets. These are the different types of nebulizer: adjustable concentric, cross flow, Babington type, ultrasonic and cross flow. The nebulizer forms a mist or aerosol of the sample. This is done by forcing the sample at high velocities through a narrow tube. The sample is mixed with a fuel and oxidant. Commonly used fuel oxidant mixtures are acetylene air and acetylene nitrous oxide. Detector. The role of detector is to convert the light signal into an electrical signal. The detector contains a photoemissive cathode and a series of diodes. The number of electrons emitted from the cathode is directly proportional to the intensity of the light beam. The electrons emitted from the cathode are accelerated to the first diode by a 90-volt potential, where the electron impact dislodge several additional 90-volt potential. After all diodes, the number of electrons finally reaching the anode is in the order of the 10 million for each incident photon. The output of detector is current measured at anode collector is still proportional to the intensity of the light, but it has been amplified over 1,000,000 times. The working of AAS is: halo cathode lamp will emit the radiation. Liquid sample is available where the unknown metals are going to be identified. Nebulizer is a component which is convert a sample into aerosol form. Burner convert the air, fuel and sample into the flame. The atom of the solids are converted to gaseous state in the atomizer. Radiation of specific wavelength is emitted by the hollow cathode lamp onto the gaseous atom in the atomizer. The monochromator focuses the specific wavelength onto the detector. The detector finds the amount of light absorbed. The concentration of atoms in the sample is directly proportional to the absorbance. The advantages of AAS are greater sensitivity. Solution, slurries and solid samples can be analyzed. Easy to tune and operate. Small sample is also enough for the analysis purpose. Disadvantages are: analytical range is relatively low. Different cathode lamps are required. Can detect only metals and some non-metals. Applications of AAS are: it is a quantitative analysis method, determination of metallic elements in biological system, determination of metallic element in food industry, determination of lead in petrol, identify in mining metal gold in rock, environmental studies, determination of lead, mercury, calcium in drinking water, ocean water and soil. These are the references are referred while doing this video. Thank you for your patience listening, watching this video and keep learning.